Well, hello there, and Happy New Year, Algebra 1 Essentials friends. I'm glad you could join me. I hope you had a nice break. It's time to jump in and do a little bit more math. Here's a warm-up for you. If you'll pause this video and work these problems out, that'd be great. All right, so let's work through these together. This is the kind of stuff we were doing before we went out on break. This is simplifying expressions, and we're going to be just kind of reviewing this. When we simplify an expression, we're not looking to solve an equation. Those two things are kind of different. These are not equations. They don't have an equal sign in them, and so we can't get down to a single number. But all we're trying to do is make it a little bit simpler. And we're going to be using this skill when we go to solve equations, which is what's coming up today. So in order to simplify this expression, we're going to be using one of two skills. One is combining like terms, and the other one is the distributive property. And sometimes you'll end up using both in an equation or an expression. So let's take a look at number one. The way you know which one to use is whether or not there's parentheses. If there's parentheses, you're probably going to use the distributive property. If there's no parentheses, you're probably not. And so in number one, we can see we want to be trying to combine like terms. Well, in order to combine like terms, you have to have like terms. And remember, like terms are terms that have the same variable or letter raised to the same power. And so taking a look at our terms, we have a 5x and we're subtracting a 12x. Those are like terms. Both of them just have an x in them, and so we can subtract them. So we take 5 x's and we subtract 12 x's, and we end up with negative 7 x's. And that's it. There's nothing more we can do. We've combined those like terms, we've simplified it, but we can't get an answer for x because there's no equal sign. There's nothing to do to get to that answer. So then we move on to number two. We have 8 c's, and we're trying to add 12 more c's. Those are like terms because both of those terms have a c in them. And so 8c plus 12c is 20 c's. And that one's done. Now take a look at number 3. Are we going to combine like terms? Well, the order of operations would force us to consider working on what's inside those parentheses first. And so if we take a look inside those parentheses, what we see is we have a 12, and we're subtracting a 3x. Notice that 12 does not have an x, but the 3 does. And so those are not like terms. So we can't combine them inside the parentheses. So this tells us that in order to simplify this expression, we're going to try the distributive property. And that will get rid of these parentheses. Notice there's a 4 snugged up right next to that parentheses on the left side. That's the 4 that we're going to use to distribute. We're going to take this 4 and we're going to multiply it by 12. 4 times 12 is 48. And then we're going to take this 4 and also multiply it by the second term and the sign that's in front of it. So if we multiply 4 times negative 3x, we get negative 12x, because a 4 times a negative 3 is negative 12, and then the x comes along for a ride. And then that's all we can do, because we can't combine 48 and 12x because they're not like terms. So that's done. Same thing is true in 4. We're going to get rid of the parentheses by distributing. We'll distribute this negative 5 onto this 3D by saying what is negative 5 times positive 3D? Well, a negative times a positive is negative. 5 times 3 is 15, and that d just comes on down. And then we're going to distribute negative 5 times negative 7. Negative times a negative is positive, and 5 times 7 is 35. Now, can we combine like terms here? No, we can't, because the 15 has a d with it, and the 35 doesn't have any letters at all, and so we are done. And that is kind of what we did before break, working with simplifying expressions by combining like terms or using the distributive property. All right, so now it's going to be a really good time for you to get out your notebook and review some stuff. Maybe you have a place where you could write some questions in that left-hand column. Maybe you have a place where you could write a summary or two. Reviewing your notes right now, just pausing the video and taking a peek at those notes will help you get into math brain, and then everything that I'm about to tell you gets in there a little bit easier. Also, you're going to want to set up your notes for taking notes during this video, so go ahead and get that done. All right, here is your essential question of the day. How can you combine like terms, then solve an equation? So we're going to take the idea of combining like terms and what we know about solving equations, and we're going to put them together. Our topic is combining like terms before solving equations. All right, make sure that topic gets into the table of contents of your notebook, and let's do this. So we're going to up the level today. We're going to take what we know about solving equations, which you've been doing for a while, and we're going to add in the idea of simplification using combining like terms. So far, to solve any equation, you create clever cancellations. In other words, you do the opposite, and then you do the same thing to both sides. Now, what we're going to do is we're going to simplify first and then solve our equation. So here's an example. We have 2x plus 3x equals 10. Now we'll be able to solve this because we have an equal sign. We're going to be able to find a value for x. What we're going to have to do first, though, is simplify and then create clever cancellations and then do the same thing to both sides. So when we say both sides, let's be clear that there's like a wall over that equal sign. And when we're talking about both sides, we're going to be combining like terms on one side and then solving. So notice on this left side we have 2x's plus 3x's. We can combine like terms because they are like terms. They both have x's. 2x's plus 3x's is 5x's. Now that's going to be equal to this 10, which doesn't need to be simplified. And now I bet you can solve that equation. This is an equation type that we've seen before, and we're going to use the division property. If we're multiplying 5 times x equals 10, to create a clever cancellation, we want to cancel that 5, and so we will do the opposite by dividing by 5 and making sure we do that to both sides. These 5's cancel, and we have x equals 10 divided by 5, or 2. And there you go. So that's how you combine like terms and then solve. Let's do more. Well, let's talk about this first. So what we've done is we've added a simplification step because equations aren't always presented to us in the simplest way. Sometimes we have to simplify first. So we're going to be adding to these steps as we move forward. So now we've added simplify, a simplify step. Before you can solve an equation, you might have to simplify. So right now what we know to do is to combine like terms on the same side. This is very important, and we'll talk about that more in just a second. Then, to solve the equation, create clever cancellations and do the same thing to both sides. Now let's do more. So here we have 4y plus 2 minus 2y equals 14. Now this is a little bit more complicated than what we've seen before as far as solving an equation. So what we're going to want to do is simplify. And the only simplify step we know so far is to combine like terms on the same side. So let's make our sides. Now on the right side we have a 14. There's nothing to do to combine like terms over there. So let's take a look at the left side. We have 4y plus 2 minus 2y. Well, what I see is that we have a pair of like terms. We have 4y and we have negative 2y. This plus 2 doesn't have anybody to match with, but we can combine 4y's minus 2y by saying 2y. What's 4y minus 2y? It's 2y. We're done with those guys. And then we haven't done anything with the plus 2, so we just bring it along. And that's going to equal the 14 that we had because there's nothing to do on that side. So we have simplified. Now, can we simplify some more? Doesn't look like we can because we don't have any more like terms. And so now we're going to start to create clever cancellations. Once you're done simplifying, then you can start solving. So let's see, we want to get rid of that 2 that doesn't have the letter, right? Remember these kind of problems where you were concentrating on the side that has the variable, but getting rid of the term that does not have the variable first. To create a clever cancellation here, you're going to subtract 2 from both sides. That creates this cancellation, and you have 2y equals 14 minus 2, or 12. And now we create another clever cancellation by getting rid of that 2 in front of the y. If you said you're going to divide by 2, you are absolutely right. Make sure you do the same thing to both sides. And we have this cancellation, and y equals 12 divided by 2, or 6. And there you go. We have solved this. So we combined like terms until we could no more, and then we used clever cancellations to solve. All right, shall we do another? Again, we have to simplify first. This right side of this equation is a little bit complicated, so we'll combine like terms as much as we can, and then we will solve. So the like terms I'm seeing are a 7x and a negative 2x, but I'm also seeing another set of like terms, a 7 and a negative 5. And so those are the like terms that we are going to combine. So the 27, we haven't done anything with that yet. And that equals 7x's minus 2x's. 7 minus 2 is 5, and 7x's minus 2x's is 5x. And then we have 7 minus 5, which is 2. A positive 7 minus 5 is a positive 2. And so there you go. And we have combined like terms. And now we're going to start creating clever cancellations because we can't combine like terms anymore. So we're going to start on the side that has the variable, but get rid of the term that doesn't. And that means we'll subtract 2 on both sides. That's a clever cancellation here. And we have 27 minus 2, which is 25 on this side. And then the 5x is left over here. And then we want to get rid of the 5 in front of the x, and so we will divide by 5, making sure we do the same thing to both sides. There's your cancellation. 25 divided by 5 is 5, and that equals x. And that is done. So what we've done is we've taken the idea of combining like terms with expressions and rolled it into what we know about solving equations. We just combined a couple of ideas. All right, here we go. This one's a little bit more complicated, but I believe in you. You can do it. It's the same thing. You're just going to simplify by combining like terms on the same side and then solving the equation by creating clever cancellations and doing the same thing to both sides. So let's create our sides. Now remember that we're just going to be combining like terms on the same side. We're not going to cross over. So on the left side, we've got a 6x. And a positive 2x. We also have a 4 minus a 10. Then notice over on the right side, we also have some like terms. We have 20 minus a 2. And so we have all kinds of simplification to do. So 6x plus 2x is 8x. So we're done with these guys. And then we have 4 minus 10, or negative 6, and we're done with these guys. That's going to equal 20 minus 2, which is 18. So we have combined all the like terms, and now it's time to solve. We're going to start on the side that does not, start on the side that does have the variable, cancel the term that does not, and so we want to add 6 to both sides, creating this cancellation. The 8x we haven't done anything with, and that's going to equal, what is 18 plus 6? 18, 19, 20, oh, it's 24. All right, and then we're going to create another cancellation by getting rid of that 8, dividing by 8, making sure we do the same thing to both sides. This cancels, and we have x equals 24 divided by 8, which I hope is 3. I'm pretty sure it's 3. And there you go. So it can get complicated, but you can still do it. The point that I'm trying to make is that it's the same steps over and over and over again. Notice that maybe you could combine like terms to simplify on each side independently, and then start to create clever cancellations and do the same thing to both sides to solve the equation itself. All right, so bottom line, first thing to do is to notice if you can simplify. The way to simplify is to combine like terms on the same side. And then, once you're done with that, you can use the techniques that we used for solving equations. Create clever cancellations and do the same thing to both sides. Now, of course, it's going to get more complicated because it's math. And math always gets more complicated. And that's why you should practice. Get good at a single skill because then we can build on that skill. Okay? Speaking of which, I got a little practice for you in the form of a quizzes. I'm really liking this quizzes site. I hope you are too. Let me know if you really hate it because I'll try to find something else. But the topic was combining like terms before solving equations. Your practice is on quizzes. It's called Solving with Combining Like Terms. The essential question, how can you combine like terms and then solve an equation, is something that you should kind of be able to answer at this point. If you cannot, that means that you and I should talk. Maybe you come to office hours. Maybe you come to our optional class time. Maybe you send me an email and we figure out something. But whatever you do, let me help you. All right, you guys, I hope the rest of your day is fabulous. Thanks for listening. Have a wonderful one. Bye-bye.